So in this video, we'll try to develop expression for radius of curvature in Newton's rings. So as we know, Newton's rings contains a set of plano convex lens. Let us represent this as L, O, L dash, which is kept on a plain glass plate AB. So this is our plain glass plate AB. And this radius of the plano convex lens is a part of spherical object. So this is the sphere. We have taken this plano convex lens from this spherical object. C is the center. C is the center of this, and the radius of this is capital. So from C to this is also capital R. And perpendicular to the plane of this surface, we have Newton's rings, formation of Newton's rings at a height of T. So the radius of this, so let me point this as N, P and Q. So the radius of this is R. From the property of circle, the property of circle, what we can write is NP into NQ is equal to NO into ND, right? So the value of NP is equal to how much? R. NQ also R. NO, the length NO is equivalent to T, and coming to the end, it is total 2R minus T. So into 2R minus T. So R square is equal to 2RT minus T square. As thickness of this Newton's ring is very small, now we can ignore T square in the expression, and we can write this as R square is equal to 2RT. From this, the thickness T is equivalent to R square by 2R. So this is one way how we can obtain T is equal to R square by 2R, or else let us proceed in a different way. So already we know NQ is equal to R, and this Cn is equal to R minus T. So joining C with this Q, this becomes capital R, radius of curvature. So now it is forming a triangle. This is forming a triangle with the name of the triangle NQC. From this NQC, using Pythagoras law, CQ square is equal to Cn square plus NQ square. So what is CQ square? R square. What about Cn? Cn is equal to R minus T whole square plus NQ is equal to small r square. So R square, so expanding this as a minus b whole square, R square minus 2RT plus T square plus R square. So R square cancel. R square is equal to 2RT minus T square, and again neglecting T square, R square is equal to 2RT. So what we will get again? T is equal to R square by 2R. So we can adapt any one of these. Either we can get this thickness either from property of circle or from the Pythagoras law. Now, as you know, T is equal to R square by 2R. This T value we will substitute in destructive condition. What is the destructive conditions for Newton's rings? 2t is equal to n lambda. So in this 2t is equal to n lambda, if you substitute 2, and what is the t value? R square by 2r is equal to n lambda. So 2 cancel. So r square is equivalent to n lambda r. So we know that r, the radius can be written as half of the diameter. We can write it as half of the diameter. So what happens is uh, d square by 4 is equal to n lambda r, or else d square, diameter square, is equal to 4n lambda r. So in this scenario, 4 is a constant, wavelength is a constant, and the radius of curvature is also constant. So what we can write is diameter square is proportional to n, or d is proportional to square root of n. So that is the relation between number of fringes versus diameter. Now our main aim of this discussion is to find out the radius of curvature. So let us assume this is center spot of the Newton's rings. So these are the rings, Newton's rings. Let me call this as nth ring, and this is n plus p3. So let us consider the diameters of nth ring and n plus p according to this one. So let me write n plus p. D n plus p whole square is equal to 4 into n plus p into lambda r, and similarly d n square is equal to 4n lambda r. So subtracting one from another, d n plus p whole square minus dn square is equal to 4n plus p lambda r minus 4n lambda r. So d n plus p whole square minus d n square is equal to 4 lambda r into n plus p minus n. So d n plus p whole square minus d n square is equal to 4p lambda r. So from this we can write the expression for radius of curvature r as d n plus p whole square minus dn square by 4p lambda. So this is the expression for the radius of curvature of given plano convex lens.